temporal modeling, event sourcing, and all these interesting topics. I'm glad to have you here, Mathias.
Thank you.
The stage is yours.
Thanks, and thanks Thomas for inviting me. So this is a picture of what we did yesterday. I'll tell you about it in a moment. So I'm an independent consultant from Belgium. I have a small company. Well, it's mostly me and some other people occasionally. And I visit companies and I help them with analysis and modeling, especially for complex environments, sometimes coding as well. And what I'm going to talk about is temporal modeling. So first of all, a word of warning, it's not going to be a programming talk. It's not going to be about code. There's never enough time. But hopefully at least it will help you to change how you look at modeling complex problems and complex environments, complex domains. So who here does this? Who models? Who is when you're trying to build some software, solve a problem? Do you go to a whiteboard? Do you make drawings? Do you have discussions about it? So maybe raise your hand if you do this regularly. Excellent, a couple of people. Right. So maybe another bit of warning. I'm not talking about when I say model. I'm not talking about an object that you persist in the database. That's something I would call an entity, maybe. We tend to call this model in software, but this is a very reductionist term, I would say, in this sense. So my argument is, in fact, that you are always modeling. You're always mental modeling. When somebody explains something to you, a client or somebody from the business comes to you and says, we want a feature that works this way and it does these things, you're already building a mental model in your head. Right? So if we do this and we don't visualize this, there's really no point, because you're building this model, but you have no idea of knowing, no way of knowing if this is what they actually meant, if this actually works for what they meant, if this reflects this, this problem well enough. So a great model is, we tend to, sometimes you hear this, especially in the domain-driven design community, where people think that a model is supposed to be an accurate representation of reality. That's not necessarily the point. Of course, we like our models to be inspired by reality. But this is a vague thing anyway. What is reality? One way of looking at reality might be completely different from somebody else's. So what we're looking for is abstractions, useful abstractions that help us solve problems. You've probably heard at some point the quote by George Box, all models are wrong, but some are useful. This is our heuristic. This is our tool for deciding, is this a valid model? If it turns out to be harder to work with than we hoped, if it's a lot of boilerplate that we have to do, if it's hard to understand, it may be beautiful, it may be very elegant, it may give you great pleasure that you were smart enough to come up with it, but it's not a very useful model, so it's not a good one. So this talk is about this, what Weinberg calls the grand dichotomy of things and process. He's talking about this in a book on system analysis and design. If you haven't heard of Weinberg, Gerald Weinberg, he was a computer programmer, not before your father was born, but before your grandfather was born. He's still alive. He's still writing books. He's written about 50 books, most of them on software and systems and analysis, quality of software, psychology of software even. Well, read all of them. But so in this book he writes about system analysis, and he says we have two ways of looking at these systems. One is things, structure, right? And the other is processes. How does this thing behave? What happens in these systems? And it turns out in software we're really over-focusing on the things. What we do is we build structural models, right? We look at artifacts, we look at state, we build an object and we make diagrams and we draw the properties of that object, but we're not really thinking a lot about how these things behave and how these systems evolve over time. So this is sort of on the processes side. That's the things that I'm really interested in. So behavior, state changes, not just state, but how do we get there and how do we move? And that's the stuff I'm looking for, especially when I'm working with clients, or what we did yesterday with the core team, trying to look at not just pages or content or articles, but how do these get built? How do these get published? What are the workflows? I think those are usually the more interesting and more complex problems. So Weinberg goes on and describes in processes, there's these three types of processes: being, behaving, and becoming. Three Bs. Right? Being is how the system maintains its structure. So it's not just about the structure, but it's the processes that help a system stay as it is. Right? It's about the constant structure over time, the things that don't change, the morphology, for example. So this is one kind of processes. How does the system keep things as they are? Second one is behaving, and this is usually the stuff that we're most interested in when building software systems. This is how does this react to inputs? So something happens, somebody does something. How does this system react? What's the next thing? What's the next thing? In fact, if you look at, there's a lot of these trends in software, reactive programming, functional reactive programming. In the front ends, we're building more things like React. The name gives it away. So it's about this behavior. It's about repeatable things, reversible processes. Somebody does something, what happens next? And then the third B, the becoming, is when the system fundamentally changes. So how this system becomes something else, right? It's the evolution of the system. It can be the learning of the system. How does this system from inputs not just react to them, but also changes itself over time? And sort of extreme cases in software could be genetic algorithms that learn from doing and that change their own parameters as they go along. So, but this is where we're interested in the development of this system. This could be, in a sense, this could be us building the system. That's also the becoming part in system analysis. We could be interested in the history of the system. How did it get to where it was? Which is something you do if you, for example, analyze your Git logs. So we tend to over-focus, as I said, on structural modeling. We look for things. Maybe you've applied this. This is probably one of the things you learned in school about object-oriented programming, a heuristic called find the nouns. Which tells, just look for the nouns and turn those into objects in your system. There's nothing wrong with that, but it's a very incomplete way of looking at this system. It's not just a bunch of things. It's not just a bunch of nouns and some relations between these things. That's structure, right? So you probably know these kind of entity relationship diagrams. They are a model, but I would argue they're not a very useful model because they don't tell us how the system behaves. Maybe there are some methods written on there that hopefully express some of this behavior. But it's still, this is scary if you talk to business people. Well, it would probably look more like this in reality. But this is a model, right? It's not, it's just one way of looking at a system. It describes how everything is connected, but it's not a very useful model. You can't really work with this. You're not going to put this on your desk and every day, oh, yes, right, oh, yeah, okay. Also, by the time you've printed it, probably it's already outdated. And somebody spent a lot of work on making that in Visio or one of these things, and they spent 2 weeks arranging this and moving all the lines. And then somebody comes in and, nobody's going to come in and say, oh, but that's wrong, that is wrong, and that is wrong. You need to change that because it looks so perfect. A lot of effort went into that. So this is sort of a side tip maybe. When you do make models, don't spend time on making them pretty. Make them, learn from it, throw them away. Throw away the model. I'm not kidding. So because the interesting thing is in the drawing, in the act of drawing, in the modeling. So I like to say the drawing is more important than the drawing. So if you have this, so the people who raise their hands, they know this. If you have this kind of discussions with other people in your team, there's some problem. Instead of typing away at your own computer, go to the whiteboard and start drawing, and you're discussing together. Because it's visual, people can comment on it, so you get a much faster feedback loop that you don't get from peer reviews, code reviews after you made a pull request. So I have an example. Who has heard of BDD, behavior-driven development? Have applied it, maybe? Okay. So, well, behavior-driven development is a way of, well, basically having conversations with the business, writing those down as scenarios, as stories, and then turning those into tests. And typically they look something like this. Well, this is sort of a straw man version of a BDD scenario, but this is kind of the structure that they typically have. As an actor in the system, as a user, in order to do these things, and then it's a bunch of given when then, given this state and given that state. So if you read this and try to be aware of your own mental process here. As a shopper, in order to buy stuff, given I have a product X with price €100, and then when I buy something or etc., or when I check out the basket. So you have a model in your head now, right? I assume you do. But now imagine that. So this was probably how somebody told us. We had a conversation and somebody wrote it down this way. Maybe it's a functional analyst. Maybe you wrote it together with the client or with the domain expert. But if the story had been something like this, so what you probably have in your head is a model where this is a table or a record of products, and there's some field price in there. That's sort of all you got from this, but probably you even have more in your head because this is a well-known domain to you, so you probably already matched this mental model that you're building to an existing mental model you already had. But that's beside the point here. What if the story had been like this? As a shop owner instead of a buyer, in order to sell stuff, given I have a product X, and given that product is priced €100 in the pricing table. So a pricing table is not a database table. A pricing table is something that a shop owner uses in the physical world, in a brick and mortar shop. They could use it to walk around the shop and sort of decide on prices in one convenient document. Right? So it's a list of all the prices of all their products, maybe to make strategic decisions about prices and discounts, etc. But because of the way this story is phrased, if you had seen this one first before the other one, your mental model would have been maybe two tables, a table or two records or two objects in your system, or two classes. One is products and the other is pricing, and they probably have some kind of relationship. But it's a different model. Again, none of these models are right or wrong. It's just that the second model would have been more convenient maybe for this kind of problem. The other one for the other. It's very trivial. This is sort of the simplest example I could come up with. But I'm trying to show you that just by the way these stories are phrased, your brain is already sort of in a certain direction. It's already triggered to build your system in a certain way, which might be suboptimal because you don't know. You haven't explored all the opportunities, all the possibilities. So when people call this behavior-driven development, given some state, given some context, when I do this, then this should be the resulting state or context. It's still very structural. I call it pseudo-behavioral. It's structural in the sense that I'm describing the structure of the system. I have these things, these resources, these states. I do this, and now I have this other set of resources and states. It's very easy to lie with this kind of tests, because when you implement them, you can still start with a state that is impossible anyway, that should never be reached in your system. So what I'm trying to say is this: the way we tell these stories tend to impose a structural model. And we are to blame. This is not the fault of this business expert or this client. In fact, we have taught them to talk in this way. Greg Young calls this our industry's grandest failure. The idea that instead of us learning the language of the business, we have taught them how to speak our language. They say, I want a grid with records representing this thing. That's not how normal people talk. That's how we taught them to speak to us. They think that that's the only language we will understand. So we're sort of pushing our problems, our complexity to them. So here's another way that you could have written this story that I think is much better. So as a shopper, in order to buy stuff, given the shop owner has priced the product at 100 euro. This is a very subtle difference, right? At least at this level. It's a very small nuance. But the idea here is that I'm not describing state. I'm not saying the product is a thing that has a price, or there's a product and there's a pricing table with a relationship. I'm not describing a structure. I'm only describing what happened. I'm describing real behavior. This is things that have happened. I'm describing the history of this shop, in a sense. Here, it's a very short history. It's just one thing that happened. Somebody put a price tag on something. But this should, in my experience, this kind of mindset, this sort of focus on behavior as opposed to structure, leads to much better models and much richer models. And I'm going to try to show that to you. So here I have a slightly more interesting example. It's still a very sort of reduced, simplified example of, but this comes from an actual client of mine. And so it's an online learning platform. People can buy into courses, and then they take the modules. They can have some interaction with the teacher, take some sort of tests, and then get grades on the individual modules, and eventually complete the entire course, maybe even get some certificate for that. And this was working nice. They brought it into production. And 1 year into production, they started to get complaints from students. And they were saying, well, my grades have disappeared. I took this module, I took the test, I got a grade, and now it's gone. I can't see it anymore. I can't see it on the site. Of course, we could say this is a bug, and we go in and we try to fix the bug. But there's something deeper there. There's a lack of a good model, I would say. If instead of, so this is actually, I'm very specifically chose this way of describing the problem on this slide, this language, because that's how the developers at my client were explaining their domain to me. They weren't saying, pupils come on and they, the story I just told you. They were. This is sort of the first thing they tell me. So I asked them, okay, what is your domain about? What is your what do you do? What's your business? And they said, well, teachers have multiple courses, each with multiple modules. Students have multiple courses. They were describing a structural relational model to me. They were not describing the actual problem, which is, I want to learn. I want to register and learn something, and get a degree and a certificate. So the kind of how do you analyze this problem? Well, there's a couple of very simple questions that help a lot to make the conversation about that behavior. So it's what changes, what kind of things change over time, and why does it change, and who does that change? Under what circumstances does this change happen, or does it not happen? How often does it change? The scale of things. If this happens, once a year, or is this something that happens a million times a minute? I hear myself. So, and the most important question: what are the consequences of that change? It's not just something that changes. It's every change has some. Well, not everyone, but a lot of them have consequences. More stuff happens. We would call these processes. So, we could take the 3 B's and say becoming. How does the learning system become what it is? Well, because the teachers are adding and removing modules. This is behavior, right? So what happens to students who already completed some of the modules that are now obsolete? So we're basically asking, what is the consequence of adding a module? What is the consequence of removing a module? Now that we ask this question, suddenly it becomes very obvious what the problem was. They had a model that was a sort of relational model. They probably had some cascading deletes in there. And so, a student is in a course, took some modules, took some tests, got a grade. That teacher suddenly decides, well, I want to change this course and remove this module and maybe make a new one. And nobody had thought of what happens, when somebody does that. So it was a very sort of, database-centric model. It's a bunch of resources, it's structure. I can remove things from that structure, but nobody had considered the consequences of doing so. So that's sort of where the bug was, of course. And the easy answer is just fix it so that when a module is removed, the grade is still there. But there's an underlying model lacking for this. So there's another way of building systems that is becoming more and more popular. Maybe you've heard of it. It's called event sourcing. It's another way of, fundamentally, it's another way of doing persistence. Instead of storing the state of the system, as we tend to do in a relational database, we store all the state changes. We store all the events that happened over time. And if we want to see the state of the system, if we want to see the artifact, then we can just project these events and build up this state, right? So we can just replay all these events, do some calculation, and we have the current state of the system. I'm not going to go into detail today of how you build these kind of systems and how you implement them and why they can be very performant, because maybe you're thinking, seeing this picture, this must be a very slow system that just eats up disk space and continuously needs to recalculate stuff. The short answer is, of course, that everything can be cached. But it's very interesting. If you're interested in event sourcing, definitely look it up. But so what happened is that, so this stream of events, it's a history. It's an append-only immutable data store with all the events that ever happened. So you have a complete history of your system, so you can calculate any kind of state that you want. So what happened is that people started building these kinds of event source systems. Well, Greg Young, who I already mentioned, I think he was here last year, wasn't he? I picked that up somewhere. And he used to build this, or he started building this for high-frequency trading kind of systems, etc. And started writing about it, and other people started picking it up. But something else grew from that. And so this is sort of a technical thing, event sourcing. How do you build a system? But people started, people like Alberto Brandolini and Marco Heimshoff and myself and some others, we started trying to come up with visualizations for this. So and this is what we did yesterday as well with the core team. So event storming is a way of visualizing events happening over time. It's fundamentally a timeline. It's as simple as that, right? So it's a model, it's a visual model, but instead of thinking about what things do we have here, we simply keep asking the question, what happened? What happens that is interesting to the business? What happens before? What happened after? How did we get here? What process follows from this? The questions I was showing earlier. What changes? What are the consequences? So going back to this example of the students and the online courses, if you model a problem like that using event storming, it would look something like, a teacher deletes so maybe a student takes a course, student takes a test, gets a grade, teacher deletes a module, and now you can see this. This is a bunch of things happening over time, and you can ask, okay, given this has happened, what are the consequences now? And the consequence, of course, this could be something that you have to discuss with the client or with the domain expert. What do you want to happen in this case? Do you want to delete the students' grades? Do you want to transfer these grades somewhere else? Do you want to keep a student on the current version of the course that they subscribed for, and only new students get the new version of the course? You can visualize these things and you can play around with it. And it's very cheap and easy. It's just like moving Post-its around. This is like the cheapest part. Well, whether it's event storming or some kind of visual modeling, this is the cheapest part in the entire software development process. After that, it just gets more expensive. And if you make mistakes, it gets even more expensive. Here, if you make a mistake, just throw away the Post-it. So how does this work? Right. This is what it looks like at the end, typically. Usually this could be like 2 hours work, 3 hours work, so never hire me for a consulting session if you don't want your office to be plastered with Post-its. So you need sort of this very large modeling surface, because if it's small, you're going to get stuck. You're going to start modeling, and as soon as your surface is full, you're going to stop modeling. People do this at a whiteboard. They're drawing, and as soon as it's full, they keep talking, but they stop drawing. So don't allow your logical solution to be constrained by your physical modeling space. This is why I bring the large rolls of paper and fill all the walls. So we can start very simple. Find some event. I drew it as a little envelope because it is essentially a message, but that's not very important here. It's just an event. It's something that has happened in the past that is interesting to the business. Invoice was paid, I'm again taking the simplest examples I can find. Invoice was paid is an event. It's even in the language of the business. It's not payment event or invoice event or something like that. It's just natural language. Invoice was paid. If I implement this in my code, the class name representing this message will be called invoice was paid. Right? So this is our first event. And then we can ask ourselves, what led to that? What caused this to happen? Right? So it's, again, it's a timeline. So now we can take another color and start looking for commands. So an event is something that has happened. It's in the past now. We can't change the past. We accept it as fact. But a command it's also a message, but this time it's a message that somebody sends to the system, trying to make the system do something. Right? So it's something that causes state to change. If you think about this in terms of HTTP, this would be a post or a put or a delete. So this could be a command, somebody telling the system, pay for this invoice. If it's some sort of, again, it's a very simple model. In reality, it would probably be some amount that is on a bank account, deposited on a bank account somewhere. We have to match that payment to our invoices in our system, etc. So in reality, it would probably be more complex than this. But depending on how involved you want your invoicing application to be. In fact, I worked for a debt collection agency, and they had a huge model for things like invoices. But so we pay for invoice. And then we can ask ourselves, when we have this command, so this is somebody asking the system to do something, but this might fail. This might fail for technical reasons, of course, database connection lost, but we don't care about that here. We're modeling processes in the business. But it could fail for some reason, and that reason is a business rule. What could the business rule here be? Well, something as simple as the paid amount should be equal to the invoice amount. If it's not equal, this invoice isn't paid. Again, we could have a conversation with the business. Does this, when we get a payment amount that is smaller than the invoice amount, do we simply refuse that payment? In this case, probably not. But you can imagine lots of business rules where there's a lot of variation in what you want the outcome to be. But so here we're saying that this is actually causing a branch in our process. There's now two directions that our process can go. Either the invoice is paid, the amount is equal, or the invoice is only partially paid because the amount was too small. And this starts some other process. Right? The following process there could be something like sending a reminder or trying to get the rest of this amount. So when I'm event storming, it's always first focused on the events. It's trying to find all the things that happened that we're interested in. Second is finding these commands. So usually it's not just one little thing like this, but sort of starting large, trying to discover the entire system, and then zooming into smaller things. Especially when we get to actually building stuff, then we zoom in and we try to model these sort of small processes. But this is sort of the general pattern. There's a command, which is typically a user trying to do something, which could be as simple as filling in a form and clicking a button. There are some business rules, constraints, invariants that determine, do we accept this command and what are the consequences of this command. And then the consequences, the outcomes are expressed as domain events. And by doing this very explicitly, so this is already a model that expresses more than just structure. Well, it doesn't express structure at all. It doesn't say anything about what my invoice object looks like. It tells me what the events are that happen to invoices. And it tells me the business rules, which are very critical. This is sort of why we built software, because there's a whole bunch of processes, at least sort of line of business applications. There's a whole bunch of processes that can have very complex business rules that we don't want the users to have to remember, or that we don't even trust the users to do correctly, that we model. So why don't we put them on our UML diagrams? They are the important thing. And by writing them out, especially writing them out in, well, I would say somewhat pseudo-mathematical notation here, you can already see if you have, you should already see that there's something missing here, right? So simply by forcing ourselves to write out business rules, we will already discover stuff, questions that we may not have thought of, asking the domain experts. So of course there's a third case where the amount that we're being paid is too large. Maybe this never happens, maybe this happens all the time. But this was in fact, if it was not a bug, at least it was sort of undefined behavior in our system before, where we had no idea what would happen when somebody paid too much. Maybe we couldn't even match the payment and this would be orphaned, and then we would send reminders and they would be very unhappy because they already paid. But now we have made it very explicit in a very cheap and easy way that business can understand. So, and this approach tends to scale very well for very complex problems, even with non-technical. This is programming with non-programmers. This is a switch case, right? You have given somebody a marker and some colored post-its, and they're programming the system for you. So, well, I like to annotate these models with some more details. For example, this little symbol here represents that when the invoice was paid, the process is done as far as we're concerned. So just to demarcate processes and see where they start and where they end. So this one ends. The other two, of course, don't end because we still have this partial payment, or we have too much money and we need to somehow give it back. So the next thing I look for is how does knowledge work in this system? A business rule is a decision point. It has some knowledge about the past of the system and makes a decision about what happens next. That's as simple a description as I can give. That's what a business rule is. So if it has knowledge about the past, and we have a temporal model anyway, we could start looking for how does this business rule, what does it need to know to make its decisions? So first of all, of course, it needs to have some, it needs to know the command. If I send a command with the payment amount in it, the invoice amount is not in there because, well, we can assume that this command can be spoofed. It's an HTTP request, for example. If I could put in the invoice amount and the payment amount, then I could set the invoice amount to 1 and the payment amount to 1, and then I have paid very cheaply and cheated the system. So the payment amount is not in there. That comes from somewhere else. So the question is again, what happened before? And before that invoice can be paid, it has to be, this customer was invoiced, for example. So this invoice somehow needs to be created in our system. Maybe it's generated, maybe it's made manually. But there's some place where this system, where this invoice comes into existence. So now we can see there's 2 arrows going back for that business rule. To make a decision, the business rule needs to know about the payment amount, which is in the command, and the invoice amount, which is in the event that happened before. And then, of course, we can ask what happened before, and there's probably another command saying invoice customer. So again, pay attention to the language here. I'm not saying invoice was created, which is not. This is a database language. This is CRUD language. In domain-driven design, we look for the language of the domain, the language that the people would speak in this, who work in this business, and they would say the customer was invoiced. They wouldn't say we created. Again, this is sort of moving away from very structural language. We have things that are created and changed and deleted, or edited and deleted, but moving to a language that expresses why we do this. In your domain, in content management, it's from sort of the structural way to describe it would be say the article status has changed to published, but that's not what we do. I mean, that's not what the business wants to do. They want to publish an article. Right? The article was published, not the status was changed, which is a very technical way of describing this. So we try to get this language in our models, this language from the domain, get this language in our models, in our code, in our documentation, in our tests. In fact, in domain-driven design, we call this idea of using that same language everywhere. We call it ubiquitous language. I love saying that, ubiquitous language. So this is sort of what happens before, and I had another mark here to say this is probably the beginning of this process. Of course, there may be other processes that happened before. Maybe there was an ordering process and a fulfillment process, and somehow we need to get this product or these services to this customer. But we can still sort of see this as an individual separate process with maybe some transfer point. And now we can ask what happens after, right? Because we had on top here, here we have the invoice was overpaid. So probably some process follows where we either reimburse this money or book it onto the next invoice, or maybe send them a discount code to make up for it, some way of making up for the mistake. And here we have a partial payment. So once again, we need to, probably the next thing that happens, well, ignoring the whole sending reminders, etc. But the next command here, the next blue thing, is again pay for invoice. And again, we have a business rule. And again, we have three possible outcomes where now the invoice is fully paid. Maybe this was 50 euros and this was 50 euros, and the invoice here was 100 euros, so now it's fully paid. Or maybe it's still not enough and it's still partially paid. Or maybe this time they paid too much and it's overpaid now. So this process is repeating. But what I like to do when I'm doing these timelines, this event storming, imagine these are just post-its. I like to have this repetition very explicitly. As developers, we always try to be very dry. Don't repeat yourself. I already drew this, so I'm just going to draw an arrow saying this repeats. But sometimes making that repetition very explicit and doing it twice or even 3 times can show you something, can learn you something about, does this system actually behave the same way if it's doing it once or if it's doing it multiple times? And what changes and what are the consequences and who does it change and how does it affect things? So again, very trivial example, but there's a slight difference in how we would describe this business rule now. Remember here we said the payment amount from the command needs to equal the invoice amount from the event. Now that's not entirely true. If we draw the arrows, it's not just 2 arrows, it's an arrow back here as well. So it's not just the invoice amount itself and the first payment, it's also the next payment, right? So we need to rephrase this business rule. It's very subtle, but it's not just the paid amount, but it's the sum of paid amounts that needs to equal the invoice amount. You probably would have discovered this when you wrote this, even if you don't model or anything, if you just do this in code. But what I'm trying to show is that by making business rules very explicit and modeling them and making them part of what you explore and how you ask questions to the domain expert and figuring out the consequences and figuring out how a certain decision gets the knowledge it needs to make a decision, gets the data it needs to make a decision, you discover this kind of stuff you never thought about, and that comes up 1 year into production when your student starts complaining that their grades are disappearing. So I think it's very valuable to try these techniques. There's more happening, of course. For example, here there could be 2 outcomes because this one here was invoices partially paid, and now we have, in fact, another partial payment here. So there's another invoice was partially paid, but the combination of these 2 is actually another event saying the invoice was fully paid. Why is this interesting? Of course, some system that is listening to these events. Maybe you put these events on a message bus somewhere and there's some other system or some other service listening to these events. It could listen to both of these, of course. Every time there's a partial payment, keep that intermediate state and then add it up and then decide, okay, now it's fully paid. But then you're really duplicating the logic of this business rule in that other thing that is also listening to these events. Whereas here, the decision is reflected in another event saying fully paid. So some systems might be only interested in invoices that are fully paid. Maybe we can only ship the product if it's fully paid. So some system might listen to every time a fully paid event comes in, I do this other thing. And some other system might be very interested in these partial paid events because it wants to, for example, it wants to analyze the payment behavior of our customers. And this is the kind of thing that we built when I was working for the debt collection company. Although we didn't do it, that was in like 2011, and we didn't do it in event sourcing yet. But so what we have done now is we have built an entirely new set of visualizations, new primitives for making our model. This is what we had, artifacts, structures, objects, or records or tables, and then some relations between it, and then maybe if we're lucky, some behavior written on that map. But usually, by the time you get there, you have spent a lot of time on drawing these things in Visio. What we have done, just with post-its and markers and some paper, is these primitives. There's time, first of all, so we see history, not just facts at one point in time, but the history of the system. We see these, I call them knowledge dependencies, these arrows going back from business rules that show us how things are connected, how a business rule needs to make its decision. Why is that interesting? Because we can now sort of see things that cluster together. If some business rules have a lot of arrows going back to some events, they will cluster together, they belong together. They are maybe something that we need to model as one cohesive whole, as one conceptual thing. Whereas if there's two processes and there's no arrows connecting them, there are probably two things. Just the sort of how the model looks and where the lines are gives us a clue of what could be a good implementation at this point. So we have the constraints, or business rules, or invariants, whatever you want to call them. We have the history. We have intentions. Somebody wants to do that. You can think of those, so the commands in blue, you can think of those as use cases even. These are the things I allow people to do with this system. Instead of saying, here's a huge form with every possible field, and you can change all of them, we're saying very specific things. In your domain, it could be, instead of we change the publication date, you could say we're allowing them to schedule the publication. It's not just changing a field, but it's changing some conceptual whole, and scheduling could mean changing the start date for the publication and the end date, and maybe when this thing is featured on the front page and when it's not. And so this is a conceptual thing. We allow people to do these things, so we can express these as commands, and these commands have names that come from the business, and it all starts to fit really nice together, especially if you combine this visual modeling style with something like event sourcing in your implementation. But even without, this helps you to find better objects. And then, of course, we have sort of processes, and you can see that this stuff clusters together. I only had one now, but if you fill the wall, you will see these sort of clusters. There's more stuff you can put the people on there, who's doing what, and queries and state, etc. But let's not go there. So, just to reinforce this point, it's not the one true model. It's just one way of looking at the system, a temporal model, a behavioral model, versus a static or structural model. But I think it was worth repeating that point. We have a little bit of time left. So there's more you can do with this. There's a lot of these processes where we can, in fact, by drawing these arrows, we start to see a certain structure. I left out the commands and the business rules here, but just imagine they are there. So instead of saying it's one huge process, it could be two processes with some kind of artifact in the middle. And this artifact is typically the thing that transfers from one business process to another. It's the end of one process, and at the same time, this artifact represents the start of the other process. So that artifact could be the actual invoice document. An invoice is a message where you say, my process of building an invoice is finished. I hand this artifact to my customer, and now the process starts of invoicing, of getting that invoice paid, debt collection. Could be a receipt in a warehouse, could be a contract. So we call these two phases collaborative construction, or planning, you will sometimes hear, and execution. So it's collaborative construction. Maybe it's not really collaborative and it's just one person, but very often they are complex things where different people are building the invoice together. Maybe the salesperson needs to add the products, and maybe the account manager needs to add some details, and maybe the Maybe somebody in charge of products needs to add the prices. And then this invoice is done. It's maybe even signed off by somebody, some manager. And this artifact is now the start of the next process. It prescribes how the next process goes. This invoice contains the information that decides, we expect you to pay us this amount by this date. It's a prescription of a process. So, well, this is the example I just described. So we could, instead of building one huge invoice object that is this massive God class, we can build 3 smaller objects. One object that represents this process of drafting the invoice. One object that represents the actual invoice, just sort of the state, the thing, the document. And then the process of invoicing itself, where we send it. So the first event is probably invoice was sent to customer. Maybe we get a payment, or maybe we get maybe they contest the invoice. Maybe we send reminders. Maybe it's a long process with lawyers, etc. And in the end, hopefully, the invoice gets paid. Same thing for our example with the online courses. We can split this up in 2 processes. One is course design, where the teachers are building the course. Then the course itself is just the artifact. We can separate that into a separate object. And then the students taking courses is a different object. We use a different model for this. I'm saying object, but it could be a set of objects or a set of models. So we can build smaller, more focused models that have their own rules and their own constraints, because the sort of constraints that apply to the concept of what a course is while you're building it are different from the concepts and behavior that applies when you're taking the course. So why build one huge object for that? So this is how, even if you don't build event source systems in object-oriented systems, you still get a benefit from looking at these at processes as opposed to structure. You will find more focused, sort of single responsibility object. This object here is only responsible for helping teachers build this thing. It doesn't represent the actual thing. When this process is done, we create the actual thing. This may look like redundancy, and well, theoretically it is. We are copying information from this process in this artifact, but that's fine. I mean, redundancy or excessive normalization is overrated anyway. In fact, I would argue that normalization is how they got into the problem with the disappearing grades in the first place. So this is the same for warehouse management. There's maybe some ordering process, and then at some point, it's very simplified here, but a truck driver comes, they have products that they're unloading. At the same time, some receiving operator it's called, has this receipt that lists all the products in that, all the stock in that shipment. And, okay, 5 of those, 10 of those. Oh, there should be 5 of those, but there's none. So that's the receiving process. It's comparing the actuals versus the plan. And then put away is moving it into the warehouse, putting it at the right place. So same kind of, again, this is not just 3 objects. This would be 3 entirely, or 4 probably models. Insurance, again, collaborative construction. You're building a contract. Maybe if you are just a private consumer, the negotiation process with an insurance company is usually very short, because they just fill in some of the basic fields, and you get the same contract. Everybody gets sort of the same contract. But if you are a very large client, this process could involve, could take weeks or months. And the contract is just the artifact. It's just a description of the things that you agreed to in this process. And then maybe years later, somebody files a claim, and now the contract prescribes how this claim proceeds. Right? So these patterns, there's another phase. I'm not going to go into detail, but we can sort of track everything that happens here. And we have it for free, because if we do event sourcing, we've stored all these events in our history. So we can do analysis on that, and then use that to improve our processes again. So this is stuff that businesses do, of course, but they usually don't think about it as these sort of nicely separated processes. So 3 archetypes: collaborative construction, execution, and then analysis. Once you see them, you start seeing them everywhere. Any kind of, well, not all business processes, but many business processes actually fit in this pattern. And even what you do, software development, you build the artifact collaboratively in Git, and then at some points you make an artifact which is the code base, the build, right? And this thing you deploy, and that's when execution starts. Literally, you execute this thing. The code prescribes how the system will behave at runtime. And then we do monitoring and analysis and looking at logs, discover bugs, and etc., and then feed back into the process. This gets a little bit more advanced now, but I still want to show this, and then I'll skip the rest of the presentation, because this is why it's so powerful to model with time. Because we can now start seeing how, by visualizing this with post-its and just making timelines, we can start drawing lines of how one process affects what happens in another process while it is running, while it is happening. Sometimes nothing, but sometimes it can be very implicit. In this case, invoice or debt collection, the invoice goes overdue. There's some implicit agreement, maybe just an email from the CFO saying, from now on, we need some money quick, so call debtors, people with invoices that are outstanding, call them after 3 days. That's just an implicit policy. But if you make a more advanced system, you could actually program that into the system, or hard-code it, or configure it, where it shows you after 3 days, it shows you a notification, call this person because their invoice is 3 days overdue. So that could be a sort of fixed coded policy, where the system tells you what to do next. And maybe just a little bit more, maybe it's call after 3 days, call again after 10 days, send an angry letter after 15 days, send a lawyer after 30 days. That could be the process. But then if you start building a SaaS debt collection thing for many, many companies, they all want their own version of it. And they don't just want their own version, they want to, again, learn from the payment behavior of their clients and start adapting this over time. So the policy changes over time. Changing the policy becomes its own process here. And it could be very involved where, if they're very big clients, maybe we make it slower and we do more friendly phone calls. Or if it's, our most important client, maybe only the CFO gets to do a phone call and, be very smooth and friendly and talk about the weather and football. And then, oh, by the way, this invoice, can you look into it? But of course, you're not going to do this approach for if you have thousands of very small invoices. So we can start having a process that over time changes the configuration of how these invoicing processes need to go. And we can start modeling that. We can start visualizing what if we have some ongoing process here and we have changes in this process, we change the configuration. How does the change in, configuration, I prefer the word policy. What if the change in policy, should it affect the ongoing processes? So it could be that there's nothing. So this is sort of, this could be a simple solution here for the course problem, where we simply say that it doesn't affect it. Meaning, when I'm in a course, I stay in that version of the course until I finish it. Even if the course changes entirely, I'm still doing the old version. But now we can ask the business. If you ask the business right after you have drawn this sort of picture, they can form a mental model of it that is, very visual. That is very. You can explain the problem. You can discover the problem and explain the problem, and visualize possible solutions, which I don't think you can with sort of traditional modeling styles, or with just conversation. Even would be very hard. So this probably wouldn't happen in a warehouse, because this process of receiving, where the truck comes in and we have to unload it and check it off and put it in the shelves, that takes maybe half an hour or an hour. If during that time somebody says we're changing our process, that's probably not going to affect things. But it could be. And it could be things like the things that are decided here is, for example, certain types of products need to go into certain areas, because maybe they're high-value products like iPhones. You don't put your iPhones just anywhere in the warehouse. You put them in a closed-off area, and only certain people have access to that. You don't allow your day-to-day hired workers to touch those. Only your fixed employees. Or it could be things like, what if we get damaged goods? Do we give them back, or do we store them, or do we store them separately and then sell them to sort of low-cost, low-budget supermarkets where they buy slightly damaged stuff and resell it, etc. And of course, it gets more interesting if you have. So that was a very short process here, but with insurance claims, if this takes years and this takes weeks or months, what if your insurance products change over time? What if your anti-fraud strategy changes? How does this affect ongoing process? You can start modeling these things. And I actually did this with a life insurance company. They were very happy to finally sort of have a way of visualizing these things. Because this is a huge problem. This is a regulation problem as well. You can't just simply change your insurance product and all your clients suddenly have to simply accept this. We can ask them for permission, but sometimes it's a lot more involved. So I wanted to show that, just to show that by making timelines and looking at behavior, you can make much deeper visualizations and have much more interesting discussions about very complex cases that you can't have that I don't know any other way to do, really. Even if your domain is not as complex as life insurance, I think it's a very valid tool to use. I'm sort of out of time. I have some stuff about implementation and versioning and how to push these policies into the process, etc. But I'm going to skip that. But the slides are on my website if you're interested. So, but this is the main point, right? If you have a complex or even just a fairly simple business process, try looking at it with a temporal model. And if you do a presentation about time, you cannot omit quotes by Einstein. So here it is. The only reason for time is so that everything doesn't happen at once. Thank you very much. If you have questions, we have a couple of minutes, I think. Nobody? Okay. Marco?
So in the beginning in the PDP approach that you proposed, where you move from state-given expression, sorry. When you move from state-driven given clauses to execution of previous steps, how do you actually run these specifications? Because that's actually what we do practically when you have something like an auction and you want to publish that auction, but the publishing date cannot be in the past.
So are you asking about what if my test is coupled to time?
Yeah.
Well, there's a simple solution for that, which is called a system clock. Instead of depending on something like date time in PHP directly, so never do that. Just depend on something you call clock or even time machine. And this can be an object that you inject in all the objects that need time. For example, just through dependency injection. And then instead of saying new date time now, you can say system clock get now or get current time or something. And then you get a date time object. But now you can mock it and you can play around with time. So even without event sourcing or anything, that's possible. With event sourcing, you have some more possibilities because you can now model the passage of time as events themselves, as discrete events. So it could be something like a day has passed is a concrete event. So now I can write a test that says, given I send an invoice, or given customer was invoiced, and given day has passed, and given day has passed, and you do this 30 times, then I want a reminder to be sent, or then the invoice became overdue. You can write a test that actually just describes the progress of time as part of the test. So it's very easy to test, in fact. I actually write this on the post-its when I model this thing. So this happens, and then plus 30 days, for example, the invoice becomes overdue. We're taking time into account. Was that what you're looking for? Okay. Any other? This is a very short answer, but any other questions? Okay. Thank you very much for listening. So slides are on the website, some blog posts. I teach workshops. I'm also the organizer of Domain-Driven Design Europe conference in Amsterdam, end of January, beginning of February. So if you're interested, check it out. Thanks.
All right, thank you, Mathias, for providing